Welcome to the true starting point of the e-learning space. So in the first couple of video recordings, we'll focus on reviewing the mathematical concepts that will be useful in the course of Econ 1210. Let me show you the table of content here, and the structure of each video clip will be more or less the same. So we'll first go through the major mathematical concepts, and afterwards, to discuss some problem sets in economics that make use of these mathematical concepts. Right, so to begin with, let's go through the review part together. So today's topic will be about ratio, and ratio express how many times one number contains another. So let's take a look at the simple example here, where there are 8 apples and 6 oranges, right? So we say that the ratio of apples to oranges is 8 to 6. So this is how we can express in ratios. Or alternatively, we also say that the ratio of oranges to apples is 6 to 8. We also have an equivalent ratio to this number. So because the ratio of apples to oranges is 8 to 6, effectively, it is also 4 to 3. So this is what it means by equivalence ratio. 4 to 3 is equals to 8 to 6. For ratio of numbers a and b, it can be expressed in the following ways. The ratio of a to b in words, a colon b, which might be the form that we often see in mathematics. And the last one is a divided by b in a fractional form. So this is how we can express ratios. And this is also what I would like to briefly go through about the mathematical concept of ratios. All right, so let's go through the application problem sets. So the first question is about the power of trade and comparative advantage. So we have a one-person economy. The only resident is John. He can produce 1 kg of banana in 2 hours and 1 kg of fish in 3 hours. So to consume 1 kg of fish, John has to give up how many units of banana? So the key for this kind of question is to find something to connect the two goods, banana and fish. So it's giving you the time needed to produce 1 unit of the goods. Why don't we try to use time to connect the two goods here? Let's say if John has 2 hours, he can either use 2 hours to produce 1 kg of banana, or he can use this 2 hours to produce less than 1 kg of fish, because he needs 3 hours to produce 1 kg of fish. If he only has 2 hours, he will produce 2 divided by 3 units of fish instead of 3 over 2f. Okay, so this is how we can construct the opportunity cost relationship here. 1b equals to 2 over 3f, or equivalently 1b equals to 0.67f. On the other hand, imagine if John has 3 hours, obviously he can use it to produce 3 kg of fish, or more than 1 kg of banana, okay? Because he only needs 2 hours for 1 kg of banana. So this is why John can produce 3 over 2 instead of 2 over 3b if he has 3 hours. Okay? So the opportunity cost relationship is as follows. 1f equals to 3 over 2b, or equivalently 1f equals to 1.5b. So we have the result as follows. To consume 1 unit of fish, John has to give up 1.5 kg of banana. All right, so this is the first part. And the second paragraph, suppose John can trade with others in the world, and the world price of banana is $8, while the world price of fish is $4. So according to the world prices, what would be the amount of banana that John has to give up to consume 1 kg of fish? So let's see. If John has $8, he can use it to buy 1 kg of bananas in the world market, or 2 units of fish in the world market. Okay, so this is how we can obtain 1b equals to 2f as the world term of trade. Okay. Imagine now, if John has only $4, then he can use it to buy 1 kg of fish, or less than 1 kg of fish. Okay, 4 divided by 8, which is 0.5b. So equivalently, 1F equals to 0.5B as a world term of trade. So again, we have the results already. To consume a unit of fish, John has to give up 0.5 kg of banana to trade in the world market. Okay, as you can see, the opportunity cost in the closed economy and the open economy would be different. Right, so the final part in this question, assume John has 60 hours. If John can trade with others in the world, then he will produce how many kg of banana and how many kg of fish. So for this part, we are going to compare John's opportunity cost of production with the world term of trade. Okay, so specifically, John's opportunity cost of producing fish will be 1.5B, which is higher than the world term of trade of trading fish, 0.5B. However, John's opportunity cost of producing banana is 0.67F, which is lower than the world term of trade of trading banana, 2F. As you can see, compared with the world market, John actually has a comparative advantage in producing banana. So this is why John should spend all his time to produce banana and buy fish in the world market if he would like to have fish. Okay? If John spent all his time to produce banana, how many units can he produce? He has 60 hours and he needs 2 hours for 1 kg of banana. So this is why John can produce 60 divided by 2 equals to 30 units of banana in total. All right, so this is for question 1. And let's move on to question 2. Actually, the question is quite the same, just that we have different information, okay, the productivity of producing banana and fish here at the beginning. Okay. So to consume 1 kg of fish, John has to give up how many units of banana? Again, we are going to use time to connect the two goods. Given 1 hour, John can use it to produce 2 kg of banana or 3 kg of fish. So this is how we can construct the opportunity cost relationship, 2B equals to 3F. Okay? And if you divide both sides of this relationship by 2, then we'll have 1B equals to 1.5F. Or if you divide both sides by 3, then you have 1F equals to 0.67B. And the result is as follows. To consume a unit of fish, John has to give up 0.67 units of banana. All right, so how about the second part? Basically, the same number as in exercise question 1. We have the same world price of banana, $8, and the same world price of fish, $4. So John will have to give up 0.5 kg of banana to consume a unit of fish. I'm not going into the details for this part again. And finally, to find out the production of John, if he has 60 hours and he's allowed to trade with others in the world. So we are going to compare his opportunity cost of production with the world term of trade again. So this time, John also has a lower opportunity cost of producing banana compared with the world term of trade. 1.5F is smaller than 2F. And this is why John should use all his time to produce banana and buy fish in the world market if you like to consume fish. Right? So he has 60 hours and he can produce 2 kg of banana in an hour. So in total, he will be able to produce 60 multiplied by 2, which is 120 kg of bananas. All right, so this is the first 2 exercise questions. And we'll move on to the next problem, okay, a past exam problem in this course. So we have the production of Stephen and Paul to perform clutch and brake replacement expressed in this production possibilities curve. In question 10, suppose 1 standard maintenance services include 1 clutch replacement and 2 brake replacement. If they work separately, what will be the number of standard maintenance services that they can perform? So we need to construct the desired production ratio here, right? Because 1 standard maintenance service includes 1 clutch replacement and 2 brake replacement. So this is why clutch to brake is in a ratio of 1 to 2. So we can write it in this form. C over B equals to 1 over 2. So this is actually the desired production ratio that I put down here. And likely, you may want to do a little bit of checking whether it can be expressed in C equals to 2B or B equals to 2C. Okay? So how can you check? From this relationship here, when C is 1, then we must have B equals to 2. On the same token, when C is equals to 2, then we must have B equals to 4, which is the pairs that I've put down here. As you can plug in these two pairs back into the yellow highlighter thing here, they cannot satisfy C equals to 2B, but they can satisfy B equals to 2C. So this is why the desired production ratio is B equals to 2C. Okay, so you can use either way to obtain the desired production ratio. All right, so there are some steps that we can follow to solve this problem. We are going to find the point on their respective production possibilities curve such that it can illustrate the desired production ratio. Okay, the intersection point would give the number of standard maintenance services that each of them can perform. At this point, let me also shift my screen to GeoGebra and to solve this question with you together. All right, so now we are going to take a look at this slide. So the first step is to label the x-intercept and the y-intercept of their respective PPC curve. So how can I do that? Because we know that the x-intercept for Stephen PPC is 194, then we just type this as the x-intercept. While for the y-intercept for Stephen's individual PPC, it will be 388. Okay, points A and B are actually 2 points on the individual PPC of Stephen. Okay, and we can move on to step 2 to find the equation of their respective PPC. How can we do that? We would use a functionality in GeoGebra. Click Tools, and then scroll down to find something called Segment. Okay, segment. What you need to do is to click the 2 points, and then GeoGebra will help you draw the line segment that pass through points A, B. And finally, we are going to draw a line that illustrates the desired production ratio. Because clutch is plotted on the y-axis while brake is plotted on the x-axis. So this is why this thing here is actually y over x equals to 1 over 2. So let's type it in GeoGebra. Right. So this point here is actually illustrating the production of clutch and brake for Stephen. Okay? He can perform 77.6 clutch replacement and 155.2 brake replacement. So in total, Stephen can perform 77.6 standard maintenance services. So we do something similar for Paul. Again, let's repeat everything together. Step 1 is to put down the x-intercept and the y-intercept of the individual PPC for Paul. Okay, we have points C and D. Step 2 is to use the segment function to join the 2 points, okay, to draw the individual PPC of Paul. Step 3 is to draw the desired production ratio, okay, the thing here. So intersection point will give us the result. Right, so we know that Paul can perform 48.5 standard maintenance services. Sum them up, 77.6 plus 48.5, it will be the total number of standard maintenance services that they can perform if they work separately. 126.1. All right, so this is the first part of the question. Question 11, if they work together, what will be the number of standard maintenance services that they can jointly perform? Again, let's see, and we have 4 steps that we can follow from this. Okay. Step 1 is to find the x and y intercepts of their joint PBC. So how can I do that? The x-intercept of their joint PBC is meaning that if they only produce brake, what would be the number of brake replacement that they can perform? It would be 194 plus 194 as the x-intercept of their combined PBC. How about the y-intercept? It is simply meaning that what will be the number of clutch replacement that they can perform if they only perform clutch replacement? It will be 388 plus 97. So this would be for step 1 to find the x and y intercepts of their joint PBC. Now step 2 is to find the king point using the opportunity cost table. So let's take a look here. So for Stephen's opportunity cost of production, he can either use all his time to produce 194 brake replacement or 388 clutch replacement. So we have 1B equals to 2C or 1C equals to 0.5B. Similarly for Paul, he can either use all his time to produce 194 brake replacement or 97 clutch replacement. So we'll have 1B equals to 0.5C or 1C equals to 0.5B. Okay, so we just need to compare the opportunity cost, and we are able to find out who has a competitive advantage in producing each thing. Okay, apparently Stephen has a competitive advantage in producing clutch replacement, and Paul has a competitive advantage in performing brake replacement. Okay, so at the king point, where they completely specialize in the good, they enjoy comparative advantage. They can perform 194 brake replacement for Paul, while 388 clutch replacement for Stephen. So point G will be the king point. Okay, let's go back a bit. Now we move on to step 3 to plot the PBC using the segment function. Again, we click segment and then just join the points together. So the portion EGF is actually the combined PBC of the 2 persons here. And we can move on to step 4, the final step, to draw a line that illustrates the desired production ratio, which is y over x equals to 1 over 2. So the intersection point between the combined PBC and the green desired ratio will give us the number of standard maintenance services that they can perform if they work together. Okay, so it will be 155.2 standard maintenance services. So to find the percentage increase if they work together, nothing special. It will be the new minus old divided by old. The so-called new is 155.2, while the so-called old will be the number that they can perform if they work separately, 126.1, as found in question 10. So after some simple calculation, you should be able to find out that the percentage increase is 23.08%. All right, so this is for the first problem in the past exam. And yeah, we'll move on to the next one. So we have the productivity of Anne and Bruce for fish and mushroom production. And if you'd like to consume the 2 goods in a ratio, fish to mushroom equals to 2 to 1, what will be the total consumption of fish in this case? So actually, we are going to follow the 4 steps that we have just demonstrated in the previous question. And to start with, we are going to find out the desired consumption ratio first. Because fish to mushroom is in a ratio of 2 to 1, so we can write the equation in the form f divided by m equals to 2 over 1. right? So again, you can do a bit of checking to see whether it's F equals to 2M or M equals to 2F. The checking has been put down here, and I'll leave the details to you. Okay, for this question, I just assume that mushroom is plotted on the x-axis and fish is plotted on the y-axis. You can actually swap that. So again, the first step is to plot the x and y intercepts of their combined PBC. Okay, if mushroom is plotted on the x-axis, the x-intercept simply means that what would be their mushroom production if they only produce mushroom? It would be 60 plus 250. Right, so this point A, the x-intercept. But for the y-intercept, it simply means that what will be their fish production if they only produce fish? It will be 30 plus 50. And this is how I get point B, the y-intercept. Step 2 is to find the king point using the opportunity cost table. So just do a little bit of check and game. So for N, given 1 day, she can either produce 30 F or 60 mushroom. So in some sense, 30 fish is equals to 60 mushroom from perspective of N. So we have the opportunity cost relationship 1F equals to 2N. So this for N, while for Bruce, something similar. Given 1 day, he can either use it to produce 50 kg of fish or 250 kg of mushroom. So they are in some sense equal. So we have 1F equals to 5M. And apparently, N has a low opportunity cost in producing fish than Bruce. Okay. So on the same token, Bruce will have a low opportunity cost of producing mushroom than N. So this is how I conclude the result here. At the king point, where they completely specialize in the good they enjoy comparative advantage, then they will have 250 mushroom produced by Bruce and 30 fish produced by N. So this is the king point. So step 3 is to use segment function to connect the points on the combined PBC. So as you can see, the orange curve here will be the combined PBC. And finally, step 4, to draw a line that illustrates the desired consumption ratio. Because we have fish to mushroom equals to 2 to 1, and we also plot fish on the y-axis, right? So this is why we are going to draw the line y over x equals to 2 in GeoGebra and find its intersection with the combined PBC. In order to solve this question, the desired fish consumption, nothing special, we just look at the y coordinate of the intersection point, 72.73 kg. All right, and finally, this problem, we have the production of Cindy and Veronica per week. And also the world price of tea is $1, while the world price of cake is $2. If they would like to jointly consume tea and cakes at a ratio of 0.8 to 1, what will be the total consumption of tea and cakes here? So for this question, we need to check the 3 key points on the combined PBC. Okay, if we recall the PBC of a 2-person economy, so we have 3 key points: the x-intercept, the y-intercept, and the king point. If we are plotting t on the x-axis, the x-intercept simply means that both of them only produce t. So what will be their total income if both of them only produce t? They can jointly produce 35 plus 18 kgs of tea, and the world price of tea is $1. So this is why their total income can be found as follows: $53 at this point. How about at the king point? So I'll assume that you are able to construct an opportunity cost table on your own and to check who has a comparative advantage in production. So here, Cindy will have a comparative advantage in producing tea, and Veronica will have a comparative advantage in producing cake. So what would be the total income at this king point? It will be 35 multiplied by 1 plus 90 multiplied by 2. And finally, at the y-intercept, where they only produce cake, the total production would be 15 kg of cake plus 90 kg of cake. And since cake is at $2 per kg, so this is why the total income will be like this, 110. And as you can see, they can earn the maximum income at the king point, and the corresponding income is 215. So we'll now apply the K method to solve this problem. What is that? If we let K to be the desired cake consumption, because T to cake is in a ratio of 0.8 to 1, then we know that T consumption will be 0.8 K. So how can we solve the unknown K here? Consider this equation where they consume everything they earn. The left-hand side of this equation is their spending on the two goods, while the right-hand side is the total income, 215, that they can earn. What would be the spending on the two goods? It would be the price of T multiplied by the quantity of T plus the price of cake multiplied by the quantity of cake. And this will be the total expenditure on the two goods. Equate that with 215, we are able to solve the unknown K, which is 76.79, and is actually the desired cake consumption already. Finally, to find out the desired T consumption, it will be 0.8 K, and the result, 61.43 kg. All right, so that's all for what I'd like to cover for this topic about ratios. Thank you for watching this video.